Okay, so there's only one question that stands in our way, okay? Once we do this question, we'll know the answers to all the questions.
Which
And
question?
then you'll know exactly what mark you got.
Oh,
No, I think the most I can get is like 6.
I don't think I did that one.
I physically can't get any.
Yeah, but that's because you missed the exam, but that's okay.
Why did you miss the exam?
Oh, because she literally only, I only met her like after the exam was already over.
Oh,
Yeah,
well then she didn't miss it.
yeah.
I thought like something happened.
No. So there are 5 lily pads on a pond. Oh. It sounds very innocent, doesn't it? And then it's like arranged in a circle. No, it's like
So how I did this question was
wait. We haven't even got what the question is yet.
okay.
I doubt it's 10.
So 5 lily pads. What's a lily pad, like this or something?
No.
It's like the thing the frog stands on and jumps on.
Yeah, yeah.
But they're usually round with like one.
Okay, so what does it mean to even be arranged in a circle? There's like
Basically it means
Makes
like
a circular shape.
okay, the circumcircle of the lily pads.
Doesn't really matter.
Okay, a frog can only jump from each lily pad. Ah, it is about frogs jumping lily pads. It's almost like it's a cliche. To an adjacent lily pad on what? A frog can only jump from each lily pad to an adjacent lily pad on either side. So the frog here can only jump to here or here.
Yeah.
Alright? How many ways are there for the frog to start on one of these lily pads, make 11 jumps, and end up where it started?
So how I did this question was it could either have the frog could either do 0 circles, 1 circle, or 2 circles.
You can only do one. It has to do
Yeah.
1 circle.
Yes, but it has to do 1 circle because if it does 0 circles, it will be an even number, and if it does 2 circles, it must be an even number. Because if you jump back and forth a lily pad, it's 2, and so if you let's say you just go 1, 2, 2.
Well, you can just go 1, 2, 3, then just do this.
1, 2, 3. 1, 2, 3.
Then it'll be 6 jumps.
Then that'll be 6 jumps, right? 1, 2, 3, and then go
We
back.
have to go back
2,
to the start. The question is how many times.
So you have to do 1, 2, 3, 4, 5, and then you can go 1,
This
2.
question bothers me so much.
Why?
Because do you have to count the number of starting pads or not?
No, it's just because every starting pad is basically the same.
And because it
So
has
do you times it by 5? I guess if the answer, if the number's bigger than 200, you'll know not to times by 5.
I'm pretty sure.
okay, so and it has to do 1 whole loop of the circle plus however many plus 3 jumps and then 3 jumps back.
Ah.
Right? Because if it does 2 complete circles, then it can't do just 1 jump and not go back to its starting point. That doesn't work.
Yeah.
Oh, that's good. Yeah, I like that.
And it can't do 0 circles either because then it would just be like jump 2 and back. It would have to be a multiple of 2. So
What
it
do you
must
mean by a circle? Just
like
5
go
jumps around.
like a circle meaning going. It already returns back to its original position.
Okay, so basically there's many.
So it already
circles.
yeah.
Like.
So because it has to jump 1 circle, right?
Hmm.
Then it has to make 3 jumps, 2 and then back.
2 and then back.
There's several combinations basically.
So it has to do like 2 back, 2 back.
I guess it can do the wasted moves anywhere, anytime, right? It can just suddenly be like.
So basically,
I did 5 choose 3. That's one combination. So how does the frog jump 3 to a lily pad and back to a lily pad 3 times? So it could jump between the same 2 lily pads 3 times. It could jump between. Wait, do you guys get what I'm saying?
No.
Oh.
So I think kind of
Oh, I guess are you doing? Are you choosing like which lily pad do you like
Okay, so
kind
it
of
could either
go off
say
your rails and
these are two lily pads, right? It could either go two back, two back, two back on two, or it could go onto two back, two back, two back, right? Or it could there would be three lily pads in each. Just pretend that there's no specific order, and the last case is that it goes to.
this is like a very it's like a very challenging question for a year 6 student, like a really strong year 6 student, because it's like
Or you could go.
I think it's easy enough to understand, but it's very hard to get it right. Yeah, like
Or you could go.
I
I think
I
I'm.
think
I think I messed up on this question because I forgot to multiply it before. It could be
Just
before, or it could be after it.
Also,
Doesn't-
it can go anti-clockwise or
Hmm.
clockwise.
Oh yeah.
that's one way. Yeah,
That's what I
you
forgot
could
that.
start wasting moves here
I
as well.
forgot that if you have
Yeah.
three, you can go here, here, and jump back here, go there, and then go back.
Yeah. So there's multiple. So while we kind of established the three cases, well, we forgot some combinations within it. Well, at least I did.
Yeah, so I think it's very important to be systematic. Okay.
So basically, first, there's basically one round circle is 5 jumps, and then there's 3 like jumps where you go to one lily pad and go back, which is 2.
Yeah.
So
Except
you can do, except there's different combinations.
because.
Yeah, so I think systematic. So what does it mean? So you want to kind of break it up in like non-overlapping cases,
Yeah.
right?
So I kind of did it like that. Like this, like, yeah, do a 5 jump, 2 jumps. But like these can also be different.
Yeah, but it could also be like a 5 and then a 4-2 and then a 5.
Yeah, I know, that's basically.
So I was kind of,
And then I see
And so we have 3 cases basically within the 3 cases. So within the case where it only does one, it returns back to same position. It can either go on 2 lily pads and goes forward, back, forward, back, forward, back. So that's 6 times. Or it could go onto 3 lily pads and spread it out. So it goes forward, back, so 4 times, plus another lily pad, forward, back. Or you could go on 3 separate lily pads and go forward, back, and then forward, back, and then forward, back.
yeah. So I guess it's impossible to like be sure.
But then there's
When-
multiple possibilities. For example, it could go clockwise and anti-clockwise. Also, it could first do the forward back and then do the whole circle. Or it could first do the whole circle, then do that. Or it could do the middle of the circle and then do that. So there's so many different possibilities.
Yeah. There's some things that can't change. So for example, like what you said at the beginning is very strong. Okay, so it has to go through like a circle. Yeah, we're all good with that. So it has to go through one circle, exactly one circle. Yeah, and it has to like waste 6 moves. Yeah.
But it's kind of wasting if it goes around in this circle. It's just wasting.
It's just wasting all its moves.
Wasting its energy.
I don't know, but maybe it was trying to. It was yeah, like it was trying to see what was on the other side.
Or it could just be wasting no moves and just wants to exercise.
Maybe the frog doesn't know how many lily pads there are, just jumping around.
Yeah. Okay, so how do we be systematic about this? Well, maybe we could. So the wasted moves they can't be like completely random, right? They're either so there's one type of wasted move that's very telling. That's when I guess you do kind of doing 3. You do 3 and then you undo 3. Yeah.
Yeah.
Also, I think there are 2048 possible rows.
2048.
2048.
I don't know.
Each maybe have 2 on.
Should we just list it out?
I guess that's what ultimately we're gonna do, but it's how long this list is gonna be.
I
That's
listed
the
it
oh
out. It's not that many. But then you have to work out for anti-clockwise.
Just type
So
2
just-
for
Yeah,
anti-clockwise.
so 2 times.
Wait, how many do you
2.
get?
But these have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 6, 7, 8.
13.
like by X, I kind of mean that you jump there, back.
Wait,
The weird.
So you're kind of doing something like this. So you're saying like this. There's one circle, right? Yeah, and that
Wait.
circle could be clockwise or anti-clockwise. Yeah.
yeah. Clockwise and anti-clockwise can, I guess, basically be like solved by.
So by symmetry, you just consider the clockwise and times it by 2.
Yeah, exactly. Because it's the same thing, just reversed.
Yeah,
Okay,
there's not many.
There won't be too many, I think, but it'll be hard to list them out without forgetting some.
Hmm.
I didn't get 10. Got something else. Wait, what was the answer for question 6?
11.
What about question 7?
Oh, it's you don't have to write. I have your paper here. I'll say just give it back to you.
My paper.
Yeah, it'll have the answers. Oh, actually, maybe it won't have the answers. So what would you want?
Question 7, 8, and 9, and 10.
7 was 101. 8 was 512. Hmm.
9 and 10. You have to prove that.
Because 9 was the even numbers and 10 was like 15, I think.
Okay. Basically didn't solve from 6 onwards. I half solved.
Okay, so Lachlan, did you want to say what you did? Is that what you had listed?
No, so basically, these are all the combinations, and then if there's basically this 6 means it jumps 3 times up and then 3 times back, and 2 and 4 means 2 up, 2 down, and this X thing means like 2, 1, 1, and then 2 back because it's a
Yeah.
combination.
Wait,
And
you know
then
how we got 6 was 3 up and then 3 down? It could also be up, down, up, down, up, down.
no, that's basically 2, 2, 2.
Oh, okay. Sure.
One, two,
And then for the ones that have 2, these mean that it has to go one way clockwise, the other anti. This can only be anti-clockwise or clockwise. This can be clockwise. You can just do 2 times 2. Or
Wait, do we have to? You know when the 5 would be like broken up? Like say they jumped 1 and then they.
yeah,
Maybe we have to times all this by 5 again.
yeah.
5 times by 5.
Because like
Times
we
what by 5?
considered that like the 5 is like a group, like it's all together. But then it could also be like split up. So it jumps 1 and then it like wastes 6 jumps and then it continues.
Yeah.
Also, too many combinations.
Or we could like split up. I think he split it up the wasted jumps, right? Yeah,
Like-
but we didn't split up the group of 5, and that's what I also didn't do in my test. So
Yeah.
it could be like 1 and then waste and then 2, 3, 4, 5.
Yeah, so there's lots of problems here. So I guess these clockwise moves aren't fundamentally different from some of those moves which just do nothing and come back, right?
Mm-hmm.
So
This question.
yeah, so if I did some moves, let me just draw some arrows. Okay, so if I draw this red arrow here, right, and then I draw this red arrow here, then I undo those two, you know?
Yeah.
Like, how many ways can I even do that diagram? Like, I haven't labeled what order I did any of those things, right? But if I just had,
It's the same thing.
let's ignore that it's not actually 11, but just suppose that was your trick, okay?
If So
Like,
we could that's true. So we could either start on the dot on the very left, or we could start on the dot in the middle. That's two ways, and then you have to times it by two because clockwise, anti-clockwise.
Basically, you kind of have to split the circle, which is into 5 parts. Like, because you can do 2 jumps the circle and then waste some jumps and 3 circle. Or you can do like 1 jump, waste and then 2 jumps.
hmm
So basically, you have to split the circle into like chunks.
I guess.
Wait, so
Mm.
about this, I think if you started on the the very right dot, and then you went to the very left, and then you came back.
hmm
You could also actually start in the middle, and then go to the left, and then come back, and then go to the right, and then come back.
Sure. I mean, there's lots of possibilities, right?
So
I mean, um,
in that,
can you see like trying to think of each one like that? It will almost never get you to the right answer, right? It's kind of like it's like, oh, have I missed one, right? But the thing is, like, if like like it's like you're like sweeping the floor, right? If you're sweeping the floor like along certain lines, then you know you're not gonna miss anything, right? But if you just sweep the floor randomly, like, are you really surprised you missed some spots?
I miss spots. This is very irrelevant, but I miss spots even when I'm sweeping the floor.
Okay, so one thing I noticed about this is kind of striking to me is like, even though it's kind of, you can't really say like this red line is, you can't say that line is definitely different than the one that's going around clockwise, right? But I do feel like you can say that the ones that are going anti-clockwise are sort of somehow different than the ones which are going clockwise, right? They have something different about them. See, because if you're going anti-clockwise, right, like you're kind of definitely like you're definitely one of the things that's gonna get cancelled, right?
So basically, there has to be a certain amount of person
Wait,
clockwise.
Yeah.
Oh,
Yeah.
so it must be 5 clockwise plus 3 clockwise plus 3 anti-clockwise, or 5 anti-clockwise plus 3 clockwise and 3 anti-clockwise.
Yeah.
That
So
narrows it down a little.
so maybe you could think of it in terms of where the anti-clockwise stuff happens.
And then
I wonder how forcing that is. So
Could you just figure out the combinations that you can put clockwise jumps and
that's actually like,
and then just and then just
so you're saying trying to figure out the combination where you can put the anti-clockwise jumps.
yeah,
yeah,
and
that's
then
just
we're just walking around.
so then you can get that for each anti-clockwise jump. It could be that it's 5 to the power of 3 because it could be 5, right? It could be the first jump could be 5, and the second jump could be 5 again, and the third jump could be 5. And the combination of jumps is times all the 3 5s each together, so it would be 5 to the power of 3. Then, if we know how many anti-clockwise jumps there are, which is 125, then we times it by 2 to reverse. Right? So then
Times what by times why times it by 2?
because we're only figuring out if there's 3 anti-clockwise. What if there's 3? What if there's 8? Because the overall, the overall one circle.
No. We're assuming it's 3 anti-clockwise, no?
It could be 3 anti-clockwise, or it could be 3 clockwise.
Yeah, but we're not in this case, right? We're assuming that the circle goes clockwise.
Mm-hmm.
Then you can basically just find the
Yeah, the combinations wouldn't it just be 125?
they just just like one.
I mean, I think it's a great. It's a certainly a significant step, but it's far from solved. So the the fact that there's 3 anti-clockwise, but can they appear like anywhere, right? I don't think they can just
I think they can be
I think
anywhere.
yeah.
Because
Technically,
they're literally just undoing whatever the clockwise did.
technically.
So I think they can be anywhere.
Because they're kind of like.
Because they're gonna
Oh,
be
so
undoing
okay, so
anyway.
you're not specifying where it's anti-clockwise
It's like-
from. You're just saying which move is an anti-clockwise
It's
move.
kind of like the only. Oh, I know. The only problem. It's kind of like you're plussing one and then minusing one is the anti-clockwise. You can plus 5 minus 5 is.
So you have like 11 moves, right? Yeah.
Yeah.
3 of them have to be anti-clockwise moves. Yeah.
Mhm.
Are you just choosing where to put them?
Oh,
I think-
oh,
But the only problem is if you go around in a circle, you might get slightly confused.
oh. So I think that what I was talking about was if each anti-clockwise move, not like the positioning of it in the 11 moves, but rather where the anti-clockwise move is going to go. Like,
Oh,
when
okay,
it goes
that's
from the
that's the
first
thing I
step
was
to the
kind of
second step.
worried about because you might not be at that point to do the anti-clockwise move, right? You have to
Do
you
it
have
anyway.
no, you can do it anywhere, but you can't do the one from the 4th lily pad anywhere, right? You have to
But
get to the 4th lily pad.
I
then.
guess
But
I'm guessing
we
that
can just look at all the
we can just
combinations
first put
that's
the
already
clock.
Yeah, no. So what she's saying is you're saying do the anti-clockwise at the 4th lily pad, whereas we're saying do the anti-clockwise at the 4th move. Yeah.
Yeah, that's right.
So one of them is always possible. So you can at any move you can always go anti-clockwise.
Yeah.
It's like it's anti-clockwise time. Boom. Yeah.
Yeah.
But you can't guarantee you're at any particular leap at that move, right?
But, so I kind of.
I feel like we're like at the answer.
But we're still far from it.
We're not far from it at all. I
yeah,
think we're like one calculation away from the answer.
I think I don't know if this works, but
Okay, so knowing it's even helps. You only have to guess half the
I got 106.
68. So what's wrong with just 11 choose 3? Like, what's wrong with that?
I don't. That's my thing.
It could.
Have you heard of 11 choose 3, this terminology? Okay, so what 11 choose 3 is, it's just so we have this symbol. It's on your calculator if you have one.
11 factorial divided by
This means the
yeah.
number of ways.
that's using
So it's
Combination.
number of ways of choosing 3 things.
11.
3 things from 11 things.
Wait.
Does that make sense? It's kind of like if you have like 11 people in a race, what's the number of ways of picking the first 3 places if you don't care what order they get, you know?
But do we care what order it is?
Huh?
Do we care what order it is?
Oh no, we care what the moves are already in order. Yeah. So
Do we need to like
Do we
time
do 11
divided by like
please?
some sort of
oh no, because if you have the second move is anti-clockwise and the third move is anti-clockwise, it doesn't matter if you switch.
Oh, okay.
You still get the same sequence of moves.
so then you have to divide that.
So 11 choose 3, right?
It's basically 11
Yeah.
factorial over like 8 factorial.
So the
times
formula for
3
this
factorial.
is 11 times 10 times 9. So this kind of thing, it's like the first part of our combinatorics syllabus, but school won't teach it to you until like year 11, is right? I think it's year 11. And it's extension 1. It's not even 2-unit maths. So like, if you wait for school, you're just doomed. So 11 times 10 times 9. So 11 times 10 times 9. So there's 11 ways to pick the first thing, right? There's 10 ways to pick the second person, 9 ways to pick the third person.
And then divide by
And then,
6.
but you don't care who's first, second, or third, so you divide by the ways you can order the 3 people. Then that's 6. So 3 times 2 times 1 is the number of ways of ordering it. And
I think the formula is just like 11 factorial equals 3 factorial times 8 factorial.
Yeah,
Like this.
yeah. Yeah, the formula is always, yeah, it's the kind of like, it's like this big complicated formula, and then for any actual number, it's like 3 numbers times
Yeah, I
4.
did it wrong. I got the number.
Okay, so remember if you forgot this is fundamental. Okay, if you're doing a fraction like this, don't times the top and the bottom. Yeah, cancel stuff.
Yeah,
Yeah.
cancel. I still.
So you get 11 times 5 times 3. Yeah.
Which is 165.
Is it?
Is it? Wait, is it?
55 times
Ooh.
3.
Okay. Yes.
Yeah, it is 160.
So
So then, and then you have to multiply by 2 because one is clockwise and then the other is anti.
yeah.
Because one has 5 clockwise, the other has 5 anti. One has 3 clockwise, one has 3 anti. So
Wait, for 11 choose 3. Would it these things all be
I think
different?
it's 2 times.
Oh, why did I do 3?
Wait, is 11 choose 3? Would all of, would the 3 things all be different things?
Yeah.
Because I think we can do the same thing. Yeah. The anti-clockwise. Oh, sorry, it's moves.
Wait, what are you saying?
Wait.
3 things are different
Never
things?
mind.
It's basically like
It's
just
it was.
placing 3
Yeah.
things on 11. And
Yeah, like it's the
Yeah.
moves.
How many ways
But
you
I
can
always
place 3
think
things?
11. Like I think of it as like the circle.
Mm.
So yeah, if
Yeah.
you guys just disregard what I said.
So I think so. If we review this question, I think. All right, let's see what do people agree. Are we done here, people?
I think
3:30. Wow.
But is it? I don't know if it's correct.
Oh, if you don't know it's correct or not, then we're not done.
But I think it's correct.
Yeah. So our job as mathematicians is to know that we're
Prove it.
correct. Yeah.
It can't be 5 times because it'll be more than this other. So
Okay. Maybe we can check it as we do the summary. How about that? And then if we have a little bit of time left over, we can I can set some of you guys up with Discord and stuff.
I don't think I'm allowed.
Yeah, that's right. All right, let's do a summary of this.